6.8.
Can you find my phone? Thank you.
Absolutely. Bye-bye.
It's non-stop.
Some model simulations were done over the past 10 years, suggesting that if the glacier more sensitive to the ocean temperature, then the projection would potentially double. We showed in that paper that a lot of seawater intruding beneath the glacier at high tide is true. We verified it's not an hypothesis, it's actually confirmed by observation. So we just get the observation at the same pace we used to do it. It's a little bit better, but it's not at the pace that we need. We are still climbing Everest in tennis shoes.
It's a glacier that's vulnerable to climate change, and it can be a major vector of sea level rise. We're going to measure its melt rates in real time. We'll also measure the size of the cavity below the floating part. That's never been done before. We'll send a robot down because we've decided that the water is too cold for us.
I hope we can keep in touch. I'm actually really interested in traveling to Greenland.
Okay, I'm going to be off the hook for a little while. Thank you. Hey.
Yeah.
I don't know how we're going to fit in here.
All ready. It's going to be about an hour 45 up there. Should be pretty smooth there. It's nice and cool. We've got 3 emergency exits on board today. Earplugs if you need them. And that's it. Any questions, guys?
Yeah, so do we have an extra headset or just leave it here behind?
Yeah, that's a good point actually. Bill, they're going to need a headset back here, right?
No.
If you
want to talk to us, just holler.
Yeah, so maybe when we get close to the lake, just wave at us when it's a good time to speak.
Okay.
I think that one will probably go down.
Yeah, you drop me.
Yeah, thanks, Casey. Thanks a lot.
At last.
Circuit breaker. Breaking on.
The landscapes are mesmerizing, absolutely beautiful. It's a privilege because it's difficult to get there. Not too many people have had the chance to go there. The glacier extends like silly putty, like a pancake dough, and they make this fantastic lobe, Piedmont lobe.
It may have moved. You can see this very fresh blue ice. The glacier must have moved recently. That blue spot there looks bright to me.
Petermann is about 20 kilometers wide, so it's very spectacular because the glacier flows in a deep canyon, analog in height and depth to the Grand Canyon. So just imagine yourself in the Grand Canyon and there's a glacier flowing through it instead of the Colorado River. And that's where you get to do your work. So it's a special place. A marine basin, that means that a lot of the ice in that basin is grounded below sea level. So we think these kinds of basins are more prone to rapid retreat from a warmer ocean. So it's one of the, I call them the 3 big guns of Greenland that can contribute to a lot of sea level rise in the coming century or so.
We'll get as far forward as possible, all right?
Yeah.
It's never easy to land on a floating ice shelf. It's kind of bumpy. You have to find a frozen lake. These lakes change from one season to the next, so you never know exactly what to expect. It's going to be the call of the pilot at the last hour to decide if he's willing to land on that or not. That's a big uncertainty. If you can't find a lake where to land, then that means the operation might not happen at all. We showed the satellite data that we had to the pilot. It's like 2-meter pixels. He asked me, do you work for the CIA?
Straight ahead. Yeah, it's right there. A bit on the low side, but it's good.
That'll do.
Hang on tight.
Okay, no rush. Mind your hands and feet.
Once we touch ground, yeah, everything starts. We got to get everything off the plane. We start to discover the place we've only seen on satellite images.
We need a photo for prosperity.
It's a bit too hazy to be extra enthusiastic.
I can't see what I'm photographing.
That's been so long that we've been planning this expedition. Days, and we've been looking at the last satellite images. The tension builds up. It's very slippery, and the risk is, yeah, you want to be too fast. And it's off. There is no noise, we're alone. And we know we've got about 6 hours before the next plane comes back. Here, the place we were is the floating tongue of the glacier. So basically, it came off the glacier a while ago, and is moving forward by something like, I think, 1 kilometer per year. When I was looking at the very high-resolution satellite image we had acquired just weeks before we went there, each pixel was 50 centimeters by 50 centimeters. I saw one point which were supposed to be very close to sea level. And the camp we had identified the furthest one, which is 6 kilometers away from where we landed. So we took the advantage when the plane was flying back to Kranak and coming to us with the rest of the equipment to do this reconnaissance on foot.
Go on, follow Didier. You need to follow Didier.
Okay.
Mind the ropes.
So many crevices. I wanted to be on the hilly part so I could see the crevices better. Here, there's too much snow. Let's go. Watch out. There are holes everywhere.
Here we go.
Benjamin,
Yeah?
stay on the slope.
Okay.
It just blew there.
Yeah.
The stick is the best way to probe. Any way we get through. Fortunately, they weren't too wide. Deep, though.
Yeah.
This is on a different scale.
What was a bit more worrying, actually, is not so much the crevasses we found there, it's like, would it be like that for 6 kilometers? The risk was more in terms of actually twisting your ankle because you step into the wrong crevasse and you break your chin or something like that.
Are you taking GPS coordinates?
Yeah, but we're nowhere near.
Yeah?
We've still got a long way to go. We've done a fifth, not even.
Really?
Oh, yeah. What have we done, a kilometer?
We need to fork off, not take a straight line. The mill's here.
I wanted to go this way. Straight ahead.
Anything that's not flat is tough. It's the crevices.
Shall I press on?
Yeah.
We've reached the fork. For me, this is it.
No, don't go down. Nothing there. Where's the hole?
It should be here, but there's nothing. It's been snowing on it. There's snow in the light blue Hesperides. Did we miss it on the satellite image? Even at 50 centimeters, these blocks are maybe 5 or 6 pixels, so... I don't know. What'd you see at the top, Eric? On the edge?
What? Nothing. It's like this.
Do you think we need to check the other side? You don't think so?
No, I don't.
Huh?
No, I don't think so.
Time for a snack?
I was a bit dubious because it was so narrow. Then the environment was quite dangerous. We were surrounded by blocks of ice that were menacing to fall over at any moment. So even though it was half the distance to our landing spot, it would have been a lot of trouble. And there were some big open cracks. I'm sure we would have had some problems with that.
We'd better be careful. We'll need somewhere to shelter tonight. So we have to set up camp before we're cold and exhausted.
Yeah.
in the plane, we had our main way of fast transportation on the ice, which was our snow dog. So snow dog is a bit like a small version of a snowmobile. And the problem of snowmobile is they're extremely good for this type of terrain, but they're huge. Like you can only fit one snowmobile on a bit inside the plane with nobody else. If you want to bring 10 planes, you can take whatever you want, you know, it's like, oh, more stuff. We were trying to take it on a smaller scale. It's not because we are scientists working on climate change issues and we can spoil the terrain, just leave trash out everywhere, use tons of fuel without considering it. So personally, I always try to balance it. That was probably the best compromise. The alternative being us putting everything on skis, which would have been a much longer way to do that. For 100 kilos of equipment, with all the down point of it, it was just perfect.
Right shore.
A 2-minute talk, since you're going to be alone. Here's the alarm gun. The cartridges slide in and out. You put one in, close it, pull this to cock it. Then you pull the trigger.
What exactly are we aiming at?
The bear.
Right.
The aim is to scare it a little. There will be a flash, a bang. It'll turn red for a few seconds.
You aim straight at him?
Oh, yes.
Okay.
It won't kill it. You're just trying to scare it. Plan B is pepper spray. Put your finger in, pull the pin, and then press and point it in the direction of the bear. It won't like the cayenne pepper, so it should leave.
Should?
Well, unless you kill it, there are no guarantees. Even then, you would need to shoot it in the right place. It's a large animal. A bear that's just curious will probably stay away. But for a bear that's hungry, this isn't enough if it's famished. So this might bother him for a bit longer, because it will really sting his eyes and nostrils. So those are your two options. Then it's a case of running faster than your colleague.
Great.
Otherwise, just make yourself very big. Make a noise. No point running, actually. It will just run after you. Make yourself very big. Open your coat. Yell. That maximizes your chances.
You can't be paranoid for everything at the same time, just because if you do that, you just never go there. But on the other hand, not assuming there is a risk is also just as bad, because you put yourself in a very strong danger. You never know. I mean, there's the random bear that can do random things and are not as expected, and that could have happened. But like, you know, any risk really.
He's coming right at you.
Hey Didier, make some videos for me. Don't let me down.
We're not far away.
They have my survival bag.
Your survival bag?
Yeah.
But survival is for sharing.
Sure.
We need to share our survival, Eric.
Not dying alone is pretty good.
Excellent.
So beautiful.
We got there, just Didier and I. It was quite a beautiful scenery. I mean, this kind of rim of vertical plate of ice just sticking straight up, like very weird shape. Didier left. I was alone by myself, completely quiet, no bird chirping or anything, because there is nobody, nothing, just me. So if I stop moving, there is no noise, or the wind maybe. And the sun was just going through with the perfect blue color of the ice, and I just loved. It was beautiful. And behind these blocks of vertical ice, there were a bit of a room before the cliff. And there were like fresh water recently refrozen again. And I was like, oh, that could be maybe some cracks that I could see on summer satellite images. Not in the winter ones, but in the summer ones, I could see there were cracks through that main crack. And I was just basically with my axe and I was just picking like that. I made a small hole and I was starting to look one side or the other. The fact that it was dark in most of the corners was pointing out I got through the ocean. On the back of my mind, I was considering maybe having to take 1 or 2 days before we could reach the ocean below us. And that was 5 minutes, basically. With all the tension that has been built up from 2 years ago when we started to design this mission, the day before when we were packing the plane, a few hours before when I was getting on the ice, and now when kind of all of the possibility of not being able to get to the ocean was actually behind us. So that was like, oh, that's nice. But I was just by myself, so you know, I did not do any kind of joy dance or anything. I just smiled very happily, and I just enjoyed myself, because then I was like, oh, I can relax, basically. Ah, yeah, now we can try our submarine. I know tomorrow we can dive.
Damn it, it's deeper than I thought. Pretty good.
We found water. Seawater. Did you taste it?
No, but looking at the color underneath, it's totally black. I have no doubt.
It's soft on the surface.
Yeah, but
That's normal.
look, black, black, and more black. It's moving like crazy.
Oh, yes.
We didn't have to bring a big drill, which is 2.5 tons of equipment and fuel to drill a hole to access the ocean.
Come on, let's go. Time to set up the tent. Let's get to work.
That cut the experiment by half in terms of duration, complexity, weight, cost. So it's a no-brainer.
Okay.
Benjamin, which tent is yours?
The small one, yes.
Yours is the small one.
Yeah.
Shall I put some pegs in for you?
Be my guest. I love pegs.
Come on.
I like this. It's a good sign of starting.
The baby is alive.
Password is a Graaltech with the GMT 2020. Capital G, capital T. Capital T. And 2020 at the end.
Ah, so you need to remember your password.
We cannot call them from Greenland.
What's the password?
It's really sensitive.
There is no kind of joystick possibility. Yeah.
For the moment, our project is still in the water. We control the fiber optics while receiving constant data. It's great, especially when you're mapping something you've never seen. We can never be sure of the size of the crevasses below, but these soundings will reveal them and unlock their secrets. Like discovering Alibaba's cave, with the treasure at the very end.
One question about that. When you get very deep, the hull will compress. My question is, when should I start to worry? If I see the pressure increasing, it could be because water ingress, or just because the hull is slightly compressing.
Before the water enter, you need to see 1,000.
Do you need a hand?
Slowly does it. Wait, this is the critical moment.
Yeah. Wait, my finger.
Sorry.
Sure about this?
Yeah.
No 36?
It's below hundreds of meters of ice. You cannot send a submarine. Drilling a hole to put instruments there is a massive effort. And there's no light underneath. You don't see nothing, so you have to use these acoustic devices and measure the echoes. We want to measure the whole cavity and do this all at once. That's the only system, to the best of my knowledge, that does that simultaneously with a 360 degrees view angle.
Does that little thing fit here?
On the edges, so I think the stab is not moving that much. I think this is going down with the pressure, and then you pull this sideways, and then crack here. For me, it's good we tried it because now we know we can't use that without redoing major changes.
I suggest we leave those in the middle, where we put the hoops.
Right.
I need you to get them lined up. It'll be like this, in fact.
Okay, fine.
Ah, I've lost my cleat.
It's pointless.
Not really. Can you pull?
It's an ocean profiler. It will measure the temperature, the salinity at each depth that it goes through. And that gives us kind of the fingerprints of the water bodies.
Could you grab that glove for me?
Sure.
That's what oceanographers do throughout the oceans of the world. They dip their CTDs everywhere, and you can trace water who've been diving down from the surface to the bottom of the ocean in Greenland all the way to Antarctica. And then you find them in the Pacific and then back to the surface. And oceanographers have been tracing the whole ocean current, mostly using those parameters.
How many meters below the surface?
Around 600, I think.
How many meters of wire do you have?
I don't know, around 600. 600. Before it was 500. Now it's probably 600 meters. We'll soon hit the bottom, in theory. We'll stop there. It hasn't hit the bottom yet. Yeah, this is the physical part.
Ocean water is like a layer cake. The heaviest water are at the bottom, the lightest are on the top. Even though we consider them as completely mixed, they don't. The salinity, quantity of salt, and the temperature are two massive impactors for the weight of the water to change. Sometimes you get dense bottom water, which are quite hot, a few degrees above freezing point.
That's actually a fundamental concept in glaciology. Everything relevant to glaciers is not something happening at the surface, it's something happening at the bed. And that's not something we can easily see. In fact, we never see it because we're not seals swimming in these areas to see that with our own eyes. In the case of glaciers terminating in ocean water, they melt in contact with the ocean water 10 to 100 times faster than they do at its surface. Everything is below. And that's what it's hard for sometimes for people to understand because we're not familiar with that world that's beneath the ice. We're not familiar at all. We can't even understand it. It's like looking at the center of the earth. Terra incognita. That's what my old mentor, Bob Thomas, used to say. When you get to some place, you measure everything you can. You don't come up with a laundry list, though, but you measure everything that's relevant to it.
We can put this here if you like.
Ultimately, I'd like to have more room. I've put my bag there, but I'll need access to that behind you.
Welcome to Open Takes.
That seems to work.
Check the throttles are in neutral. Internal alert. Radio inactive.
Now, what's all this? Yes, it worked.
Careful, you're caught in the tent.
Can't you go any higher? It's okay. You can let go.
Now the question is, would he work in this huge fjord? It would be so small and so far away. So we were pushing the limits of what the sonar was designed for, because we always do that. You know, it's like trying to make it as small as you can, trying to make it as light as you can, but at the end, it's always to the limit of what you can do.
Yes, I can see it now.
We're not talking about 50, 70 meters deep. We were talking about 600 meters between the bottom and the ice keel below the water, so that it's much bigger. And there is not that many lakes that I know where you can test that.
It's good to see that at least we can see the top. It's one more step forward, you know, it's like baby steps, but the bottom is quite far down, so we'll have to go down much further to actually see it. We can't see both right now. Hopefully, as we go down, we'll get to that.
So, if you got the submarine like in a cross view, and basically we've got 4 transmitters in each quadrant, and they shine in their respective quadrants. So each of them will look on their side. Now, if you got the bottom of the ocean, a signal which will go out from that transmitter will hit the bottom and then comes back. But in addition to the transmitter, there is also 2 other receivers on the side, or we use the 3 of them, and each of them will see the returning wave. And what we want to do is we want to compare the time they arrive in each of them. If, let's say, you've got a keel of the glacier like that, this is the glacier, and the signal goes like this and comes back, this one will get the signal first, then this one, and then this one. We've got an angle and a time, which allowed us to work out each point of the seabed or the ice keel. And we do that for each of the 4 quadrants. So we get a 360 view. All of this contour, as the submarine moves forward, it will be mapping each of the places of the cavity up and down at once.
Whoa, dolphins. All hands on deck.
I'll show you around. Here we have the wheelhouse, engines, GPS, depth sounder. Over here is my parents' bedroom. Bigger would be better, but it's all we have, so we make do. This is the children's room, where we all sleep. Here's a desk for our schoolwork.
Florent is baking us some bread.
We'll wipe everything.
Nolwenn is very studious, as you can see.
Can we stop with the insults?
Here you go, Nolwenn.
How's it looking, Dad?
Damn it.
So, will it blow up?
Does this repair work?
We just put it back together. We'll see.
You engaged it?
Yeah. It's warped. Should be good to go now.
Can't beat a drop of cucumber tea.
Yeah. A cross between cucumber ice cream and cucumber tea.
We're 32 meter deep right now. We're trying to equilibrate the submarine. The problem we have is on the top we've got a layer of pure fresh water, which we can drink. Below that we've got the seawater, and for the submarine to be able to go through the seawater, it has to be heavy enough for that. Right now, at every test we did, he went through the freshwater just like if he was thinking, and then he suddenly stopped at 63 meters. So right now we are just about 63 meters, and he just stopped again. We can't get it. We've just added like 300 grams, and he just can't get through. So one more time. I think I've stopped dreaming about perfect data a while ago. I did when I was a young student, and I discovered they never exist. So keep digging into what you have, because you can find some very good gems in them. But what I think I'm good at is trying to get the best out of what we have, and trying to scrap all the knowledge that we can in the time, space, and equipment we have. All of the knowledge is like a ball or something like that. We've got to poke through the edges. Then you need multiple teams to work on different parts of that sphere of knowledge to poke a bit further. And then when you get these different concepts, you challenge them, and then you get a consensus throughout the community of researchers. We were out there just poking a tiny bit of that sphere of knowledge. So everyone can take advantage of that to inspire themselves or to challenge it. This is this perpetual challenging of ideas and measurements, and is important for the science to grow organically and quite safely, I would say. If you don't challenge yourself, it's maybe a bit dangerous, because you might end up just believing in yourself, which is different from trying to understand how the world is really working.